Hi everyone, and welcome to today's video for PROG1198. Today we're going to be talking about user-defined data types. So let's get started. A user-defined data type is a specialized data type that you can create in TSQL. Typically we use this when we have a common format or style of data that is required multiple times in various tables throughout your database. Common examples include name, phone number, and email address. Those are things that appear in various places and are often formatted the same way and/or have to follow the same rules. The user-defined data types are created and based on existing data types in SQL. When we want to create a user-defined data type, we need to complete the following. So the first is we want to determine whether or not we have a requirement for a user-defined data type. Most often, we would just use a regular data type such as int or varchar or bit. Any of the built-in data types most of the time do the job. Usually, the only time that we would want to go to all the extra trouble of creating a user-defined data type is if we know that we're going to be creating the same type of column over and over and over again. And when we're creating the same type of column, say for example, with email address, it comes with its own rules about null or not null and defaults and constraints and size and so on and so forth. So when we have the ability to reduce that repetition of creating the same type of thing over and over again, that's when we want to consider creating a user-defined data type. So when we want to create it, we first choose a name for it. And then we decide what the underlying type and size, if needed, should be. So we decide what data type we are basing our custom data type on. And if it's a data type with a size, for example, decimal, you also need to decide what size you're going to assign. Because remember, every time you use this data type, it's going to always have that same setup. From there, we would consider what kind of constraints we would want to put on our data type, such as not null, default, and rule. So we're going to be also looking at creating a rule constraint today. A rule is similar to a check constraint, and we'll discuss more about the differences between check and rule a little bit later in this video. Once the data type is created, you can use it in any tables you create from there on. You can also use it to create new columns in existing tables. So let's work our way through an example. In this example, we're going to create a user-defined data type to represent weight. The sample data here shows 45.6 kilograms. So if we're looking at a weight value, we have to consider the sample data. You can see there's a decimal point here, so we don't want to choose integer. We know it's kilograms, so we have a bit of an idea about the precision and the scale that we want for the size. So for this data type, I've assigned that the underlying type should be decimal, and the size is going to be 5,1. So that means 5 digits, one of which is after the decimal point. From there, our maximum weight can be determined as 9,999.9. Now, we know that decimal also includes negative values. However, for a weight type, when you're weighing something, you can never have a negative weight. 0 is the absolute minimum weight we can have. So one of the requirements that we would consider is adding a rule to this data type that a weight type cannot be less than 0. Some other requirements to consider are what should the default be. If we're not provided a value, we can assign a default to this weight data type, and whether it should be null or not null. So now that we've got the planning out of the way, we would start by writing a create statement to name the type and specify its underlying data type. Adding not null, this is where you do it if required. We want to get that not null in there as soon as the type is created. So we start off with a create statement followed by the word type, and then you give your name. So I've decided to name it weight, Notice that I've enclosed it in square brackets just to denote that it's going to be the name of the type there, similar to how we would do for the name of a column. The square brackets are sometimes optional depending on what you choose for the name. However, I like to include them because then if you've chosen something that is a reserved word or has a space in it or anything like that, it will continue to be contained. We use the word from to indicate the underlying type, which I already determined was going to be decimal 5,1, and I've added not null. So whenever we create a column that is of weight type, that column is already going to have a not null constraint assigned to it. Now notice the go statement here. The go statement, that's our batch separator, and it makes sure that the create statement is executed and completed before continuing on with whatever comes next, because presumably whatever comes next could potentially be using this weight type, so we have to make sure it already pre-exists in the system. We can't have it sitting around in a buffer waiting to execute. Meanwhile, we're trying to reference it. So we have the go in there to ensure that this batch is complete before the next one begins. Now I'm going to put this code into our SQL Server so that we can create the weight type. And I'll just pause the video while I type that. So here's our statement that creates the weight data type. I'm going to execute that and make sure that it executed successfully. Now, in order to verify that our data type worked and was created, we're going to take a look at all of the types in the system by using this statement here. We're going to select all from sys.types. If we execute that, we can see a list of all kinds of data types. And I might have to move up a little bit here. But we see at the very bottom, there's the newly created weight type. And we can find some other information about the data type by looking at the other fields in the result set. So the maximum length, the precision, and the scale. You can see the 5,1 that I've created. So we have this brand new data type that we have created that is waiting to be assigned now when we create new columns. Now we have to move on to applying some of those rules that we decided. So first we'll look at adding a default value. In order to add a default value for this data type, now keep in mind it's not unique to every table where you make the data type, it's unique to the data type itself. So we're determining what the default is going to be for any values of this data type if a value isn't provided. So we have two steps here. We have to create another object in the system, the default object. Now we've created default constraints before, but whenever we created them, we automatically assign them right away to a column. Now I'm creating the default constraint that stands alone. So in order to create the default object separately, let's just take a look in here again. If we take a look at sys.objects, we can see all of the user-defined objects that I've created here, and if we scroll down, you'll see that some of them are these default objects. If we look at the type description, here's a default constraint here. So the default is an object on its own. Every time we've looked at it, it has automatically been created and then right away assigned to an object. But we can create the default on its own and then perform the assignment later. And the assignment here is called the bind. So the first step here is to create the default constraint object. I've got a little typo in my slides here. That should be df, not def. The prefix for default should be df. So we're going to say create default and then give it a name starting with df that indicates what we're representing. We use the word as to indicate that the value is about to come, and we're using 0.0 here. So if we didn't specify a value for weight, the default will be 0.0. And again, we use go to make sure that the batch completes before we move on, because the second step now is to connect those two things together. We want to bind the default object to our weight user-defined data type. And we use a built-in stored procedure for this. Now we're not going to be looking at user-defined stored procedure for a couple weeks yet, but SQL Server also has a lot of built-in procedures that we can use. We've looked at a couple of them kind of in passing in one of the past videos, but this one here is a stored procedure to bind a default. So the name kind of gives that away, but notice there's only one D in the middle. So we're going to execute that procedure to bind the default. We provide the name of the default object that we get from here, and then we provide the name of the user-defined data type, which we got from the previous screen. So here the name is weight, and there it is weight also. So those need to match exactly. So let's put these next two lines. We've already created the weight. I'll just move down underneath this one. Now we're going to create the default. Now I've chosen the name weight0 to indicate that this is going to be the default for the weight data type, and it obviously indicates that the weight is going to be 0. So we can execute this to create that next object. And again, I can look at sys.objects to make sure that it is there. Let me just scroll down to the bottom of the objects. They're not necessarily going to be in any particular order. If you want to add a where line, we can look for a specific name. And this is where having a good naming convention comes in handy, that we can pick out all the objects that start with df, and that will show us the default constraints. So there's a few from some other tables, but here's the one that I just created. A default constraint for the weight being 0. And you'll notice it has no parent object just yet. So this default value is not yet bound to our weight data type. So that's our next step, executing the bind default. So we want to connect that default constraint object to our data type. Execute sp bind default. Oops. And we're connecting weight0 to our weight data type. So we can execute that. And it says the new default has been bound to columns of the specified user data type. Let's look again at our system.objects. You'll see now that it's still not connected to any parent object because we haven't used it in any table yet. So now we've got our data type with the correct size, we've got the default, we've got the not null. The only thing left was the rule indicating that it can't be less than 0. So we're going to look at creating a rule, and creating a rule is similar to creating a default in that both of them are creating a standalone object in the database system, and from there we can take that object and bind it to the data type object. So this is very similar, but you'll notice that the syntax is a little bit different. So I wrote that it's similar to a check constraint, but the difference is when you're writing a check constraint, you write it and you have the name of the column. Like you would say where date of birth is less than today's date. But in this case, because it's not connected to any column, we don't have a column name. So when we're writing the comparison operation, in this case saying that the weight has to be greater than or equal to 0, this thing here can't be the name of any column. What it has to do is represent any incoming value. So we create a variable. Notice the @ symbol indicates a variable in TSQL, and we're going to learn more about variables in a future class. You can name that variable whatever you like. I've named it WT to indicate weight. So this rule is telling us that the incoming value represented by this variable has to be greater than or equal to 0. Once we have created the rule, then again, we want to execute the binding statement that connects the rule to the data type. So it's very similar. And I'll just put this code into our sample so that we can keep our script going. So let's go back here and we'll get the rest of that code in this area. Okay, so I just paused the video while I typed all of that, and we can execute these two lines of code, one to create the rule object and then the next one to connect the two. So we execute that and we get this success message again that this rule is bound to that data type. So now the weight data type, we have specified everything that we want to say about it. Now we can use the weight data type in any table create statements. Now before we do that, just a little note about the difference between check and rule. Check constraints are defined at the table or at the column level. So a check constraint can be applied to a column when you're creating that table or after, but the table has to be involved. Rules are defined at database level. So you can create one rule and apply it or bind it to multiple objects. Check constraints can be bound to columns only. Rules can be bound to columns or user-defined data types. So they're very, very similar. It's the same kind of logic with, less than, greater than, equal to, like, all of that stuff is available in both. It's just about what you can do with them. I do want to note, though, that check is preferred, so use it when you can. You can create a rule and then apply that rule to a column on a table, but it is extremely rare to do that. The only time that you need to do a rule is if you're using a UDDT, because check constraints can be used on a column. Okay, so let's take a look at some notes about rules here. User-defined data types can be used in two different situations: a create table statement or a declare statement. Now we know all about create table statements. We haven't learned about declare statements yet. We're going to get to that in a future class, and when we do get there, we'll take a look at using a user-defined data type in a declare statement. For now, we're going to focus on creating a table, but I do want to point this out and make sure that it's in the record about rules. If you're using a declare statement, declare is used for declaring a variable. If you declare a variable of a user-defined type, the rules are not enforced on that variable. If we want to change a rule, the steps to follow for that are as follows. Unbind the existing rule from the objects that it is bound to. Drop the rule from the database. Create a new rule, and then bind the new rule to the objects. There's no alter statement for rules. All right, let's do our example. How can we use our weight data type when we're creating a table? Just move down a little bit. I'm going to create a table. Let's call it dog test. And the dog test table is going to have information about dogs. So we're going to create an identity column, dog ID. And I'm taking a few shortcuts here as far as naming my constraints, but I want to just have this lesson focus on rules and user-defined data types. So yes, I didn't name my primary key, but we can move on from that now. Okay, dog name. And dog weight. Now, dog weight can use our special weight defined data type. Notice how when I type it, it recognizes that that's my user-defined data type. It gives me some information about the constraints on this data type. So the size is 5.1, it's not null. I'm using it just like any other data type. Also notice it's not case sensitive. Nothing in SQL Server is case sensitive, unless you explicitly force it so. So we can say that that is a weight, and by saying that that is a weight, it will enforce all of the rules and constraints that we applied to weight objects. So let's execute this, and we will take a look at what's in our dog test table. Now we know it's going to be nothing, but we also know that we are going to have 3 columns. So we don't have any values here yet. But when we do insert a record, I'm going to insert values for name and weight. Don't think we need to move down. Okay, so our first dog is Fido, and Fido's weight 55.3 kilograms. That is one very large dog, but we're just having some fun here, so we can execute that. Let's take a look at what we have now in dog test. It's looking good. We were able to successfully add that weight. Let's practice some others. If I just put in a name, and I left weight blank, notice how it's using my default value. Now that default value, as you can see, was not specified as part of the create statement. It's coming from the default assigned to this data type. So I can leave that blank and get 0.0 as the default. One more test. Let's insert a third option with an invalid weight according to the rule. So we've got Fluffy here, and for some reason Fluffy has a negative weight. Now weight is based on decimal 5.1, so this would fit into decimal 5.1, but keep in mind we created that rule earlier that said that the weight has to be greater than or equal to 0. So if I try to insert this, you can see that I am not allowed to do that because of the rule. We can look across here and it tells us that the dog weight column has this rule applied to it. Because of the rule that's bound to it, we can't assign a value that is less than 0. So let's take a look again at that rule right here. All right, now one more little demonstration here. What happens if I want to avoid the default value for dog weight? So we have a dog named Sam, and I want null here as the weight. We can execute that, and you can see that the not null constraint is also being enforced. Now, again, look at the create statement. I did not say not null here. The not null is part of the user-defined data type. So that works enforcing as far as inserts. It also works for update statements. If I update existing record, let's try to update an existing dog record here. If I try to set, this is the first one, Fido, weight to null, I get the same issue here, where that data type has a not null constraint. So that's all for user-defined data types. They can be very useful if you are doing the same rules, sizes, and constraints on multiple columns across multiple different tables. I demonstrated how to use the data type here, but I could create other tables as well that all use the same data type. So if we had something like this that was a completely different kind of situation, we'll have to put in the int pieces here. I can use that again in a completely different situation without having to remake all the rules, defaults, and constraints. As long as they both follow the same format, then we can use the data type and all of its associated rules, defaults, and constraints over and over and over again in all different places inside our database. So it's a handy thing to know, and now you know it too. Hope you enjoyed this video, and if you have any questions, send me an email or drop into any of our Collaborate sessions throughout the week. Until next time, have a great night.